wave nature of electromagnetic radiation. It can be defined as a form of energy that is produced by the movement of electrically charged particles by oscillating magnetic and electric field. Properties of electromagnetic radiation. They consist of both magnetic field and electric fields which are perpendicular to each other and also perpendicular to the direction of the wave propagation. They do not require any medium for their propagation. In vacuum, they travel with the speed of light. They differ from each other in terms of frequencies and the wavelength. Electromagnetic spectrum. Arrangement of various electromagnetic radiation in increasing or decreasing order of wavelengths of frequency. IR greater than microwave, cosmic greater than gamma rays, greater than X rays, greater than UV, greater than visible, greater than infrared, greater than microwave, greater than radio wave. Dual nature of electromagnetic radiation. Wave nature of electromagnetic radiation was able to explain the phenomena like diffraction and interference, but it was unable to explain black body radiation, photoelectric effect, variation of heat capacity of solids with temperature, hydrogen spectrum. Planck's quantum theory. According to Planck's quantum theory, different atoms and molecules can emit or absorb energy in the form of discrete packets of energy. The smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation is known as quantum. In case of light, the quantum of energy is called the photon. The energy of photon is directly proportional to the frequency of the radiation, E equal to hc by lambda. Energy of one photon E equal to 12,400 lambda is not at EB. 1 EB 1.6 10 by minus 19 coulomb. Energy absorbed equal to energy emitted 1 by lambda equal to 1 by lambda 1 plus 1 by lambda 2. Photoelectric effect. Photoelectric effect is the process of emission of electron from the surface of metal when a photon of certain frequency is incident to a metal surface. The electron emitted is called photoelectron and current is known as photocurrent. Threshold frequency observation V naught. The minimum frequency which is required to remove an electron from the metal surface. Threshold frequency E naught or phi. The minimum energy which is required to remove an electron from the metal surface. E naught Q equal to h v naught. There is no time lag between ejection of electron and the striking of photon to the metal surface. Number of photoelectron. Number of photoelectron is directly intensity of light, independent of frequency of light. Kinetic energy of photoelectron. K of photoelectron directly proportional frequency of light, independent of intensity of light. A stopping potential. The negative potential which is required to stop the most energetic electron is known as stopping potential, K EBS. Explanation of photoelectric effect. Einstein got the explanation. So Hb equal to Hb naught plus Ke. Bo threshold frequency, H Planck constant, B frequency of incident like Ke minus Hbo half MB square H MB minus B naught. A spectrum. A spectrum is a set of wavelength that is characteristic or of electromagnetic radiation which is emitted or absorbed by a particular object, substance, atom, or molecule. Continuous spectrum. The requirement for a continuous spectrum is that it should contain all the wavelengths within a given range. This continuous or linear spectrum. It is defined as a spectrum between a range of wavelength that contains breaks or gaps in terms of the wavelength include the emission line spectrum. When a beam of electromagnetic radiation is sent through a sample of atoms or molecules, the electron in them absorb energy and transfer themselves to a higher energy state. Then they fall back to the earlier energy states they occupied by giving away additional energy they absorb. When the released energy is plotted against the wavelength, it is called an emission spectrum. Absorption line spectrum. When electromagnetic spectrum is passed through a certain material, some characteristic wavelengths are absorbed by the elements in the material. Due to the absence of this absorbed electromagnetic radiation, dark lines appear in the spectrum. Hydrogen spectrum wavelength B 1 by lambda 109677 1 by n1 square minus 1 by n2 square centimeter inverse. B the 1 by lambda 1.09677 into 10 by 7 1 by n1 square minus 1 by n2 square n minus Lyman 1 2 3 4 Lyman Balmer Pasteur bracket Puffin Humphrey. Black body radiation. The ideal body which emits and absorbs all the frequency is called black body, and the radiation emitted by such body is called black body radiation. The intensity of emitted radiation at given temperature increases with the decrease in wavelength. It attains a maximum value of a given wavelength and then starts decreasing with further decrease in wavelength. These experimental results cannot be explained by wave nature of light. Bohr's model postulates electron revolve around the nucleus in a stable orbit without emission of radiant energy. Each orbit has a different energy and is called an energy cell or energy level. The lowest possible energy state for an electron is known as its ground state, and the other higher energy states are known as excited state. Energy of an electron changes only when an electron undergoes transition from one energy level to other. Frequency of radiation emitted or absorbed is given by delta E by H. Electron is allowed to revolve in only those orbits for which orbital angular momentum is an integral multiple of h by 2 pi mb and h by 2 pi. Bohr's model for hydrogen and hydrogen-like substances. Let an electron of mass m is moving in an orbit of radius r with velocity v. Electronic force of attraction centrifugal force kgd square by mb square. R equal to n square h square by 4 pi square m kgd square. 0.529 into n square by z n a naught. Rn directly proportional n square, Rn directly inversely proportional 1 by z. For hydrogen, Rn equal to R1 n square. Velocity of electron B equal to 2.18 into 10 by 8 into z by n centimeter per second. B equal to 2.18 into 10 by 6 into z by n meter per second. B n equal to v by 2 pi r. N directly proportional z square by n cube inversely proportional. T equal to 2 pi r by v. T is directly inversely proportional n cube by z square. K half kg d square by r. P minus kg d square by r. T minus kg d square by 2 r. En minus 2.8 into 10 by 18 into z square by n square joule. 1 ev 1.6 into 10 by minus 19 joule. En minus 13.6 into z square by n square ev 1 calorie. 4.8 joule approx 4.2 joule. Order of energy E2 minus E1 greater than E3 minus E2 greater than E4 minus E3 greater than E5 minus E4. Limitations of Bohr's atomic core. It could not explain the line spectra of atoms containing more than one electron atom. It failed to explain the Zeeman effect when the several spectral lines is split into several components in the presence of the magnetic field. It failed to explain the Stark effect when the spectral lines get split up into the fine lines in the presence of an electric field. With the help of a high resolving spectroscope, it was observed that a single line in hydrogen spectrum consists of two or more closely spaced lines, doublet or triplet. Bohr was unable to explain the observation. It is in violation of the Heisenberg uncertainty principle. Total number of spectral lines formed when an electron undergoes the transition from N2 to N1, N2 greater than N1, N2 minus N1 by N2 minus N1 plus 1 by 2. Ionization energy I minus 13.6 into Z square EV, I 2.1 into 10 by minus 18 into Z square joule. No 3 separation SC plus 13.6 into Z square by N square EV, SC plus 2.18 into 10 by minus 18 into Z square by N square joule. Dual nature of matter. Louis de Broglie proposed that all the matter should exhibit particle as well as wave nature. Just like white light has both momentum and wavelength, all the matter including electrons should have momentum and wavelength. Lambda equal to h by mb h by p. Lambda equal to h by p h by mb 2 h by 2 under root 2 mke h by under root 2 m cube. Lambda 12.27 under by under root b 1 a naught. Lambda p plus 0.286 under root b a naught. 1 angstrom 10 by minus 10 meter. Alpha particle 0.0101 under root b a naught. Lambda neutron 0.286 keV a naught. Lambda equal to h by under root 3 mki. Quantization of orbital angular momentum. 2 pi rn equal to n lambda. Number of waves formed by electron revolving in nth orbit in one column. Lambda directly inversely 1 by m. For microscopic particle, m increase, lambda decrease insignificant. For microscopic particle, m decrease, lambda increase significant. It is significant for microscopic particles only. Heisenberg uncertainty principle. It is impossible to measure simultaneously the proton position and momentum of a small microscopic moving particle with absolute accuracy or certainty. If an attempt is made to measure any one of these two quantities with higher accuracy, the other becomes less accurate. Delta P is uncertain momentum. Delta P into delta x greater than equal to h by 4 pi. Delta B into delta x greater than equal to h by 4 pi m. For macroscopic particle, m increase, delta x into delta b increase insignificant. It is significant for microscopic particles only. Alpha, proton, electron, neutron. Reason for the failure of Bohr's atomic model. The wave character of the electron is not considered in Bohr model. According to Bohr model, an orbit is a clearly defined path, and this path can completely be defined only if both the position and the velocity of the electron are known exactly at the same time. This is not possible according to Heisenberg uncertainty principle. Quantum mechanical atomic model, which is based on the particle and wave nature of the electron, is known as the wave or quantum mechanical model of the atom. This model describes the electron as a three-dimensional wave in the electronic field of positively charged nucleus. Schrödinger derived an equation which describes wave motion of an electron. Del square del square psi plus by del x square plus del square psi by del y square plus del square psi by del z square plus 8 pi square m by h square e minus psi equal to 0. H cap Hamiltonian operator. Significance of psi wave function. The orbital wave function is just a mathematical function and it has no physical significance. All the information about the electron in an atom is stored in an orbital wave function. Significance of psi square probability density. The probability of finding electron of a point within an atom is proportional to a square of orbital wave function, that is psi square, at that point. It is known as probability density and is always positive. The region within an atom where the probability of finding an electron is maximum is known as orbital quantum number. It may be defined as the set of 4 numbers with the help of which we can give the complete information about an electron. Principal quantum number n, azimuthal quantum number L, magnetic quantum number m or ml, spin quantum s or ms. Principal quantum number n. It is a positive integer with the value n equal to 1 to 3. It tells about the cell to which an electron belongs. It tells about the energy of electron. Energy of electron directly proportional n. It tells about the size of a cell. Size of a cell directly proportional n. Maximum number of electron in a subcell equal to 2n square. Maximum number of orbital in a cell equal to n square. Azimuthal quantum number L. It is also known as orbital angular momentum or subsidiary quantum number. It tells about the subcell to which an electron belongs and the shape of the subcell. For a given value of n, L can have values ranging from 0 to n minus 1. Maximum number of subcells in a cell is equal to the value of n. Magnetic quantum number. It determines the number of preferred orientation of an electron in a subset or the number of orbitals in a subset. For a given value of L, 2 L plus 1 values of M are possible ranging from -1 to +1. This quantum number explains the splitting of a spectral line in the presence of magnetic field M minus L to plus L, including 0. L S subcell spherical and directional in nature. P subcell dumppable directional in nature. D subcell double dump. Express dz square. Dz square dx square minus y square. Axial orbital dxy dyz dzx non-axial orbital. Spin quantum number. Electron rotates on its own axis in clockwise or anti-clockwise direction. So spin quantum number can have two values of plus half and minus half. An orbital can have maximum of 2 electrons with opposite spin. For hydrogen single electron spacing. Energy of atomic orbital depends only on n. Higher the value of n, higher is the energy. Degenerate orbital having same energy. For multi-electron elements, energy of atomic orbital depends on the value of both n and l. Bohr-Bari rule. Higher the value of n plus l, higher the atomic orbital. For orbital having same value of n plus l, higher the value of n, higher the energy of atomic orbital. Note the region within an atom where the probability of finding an electron is 0 is known as node. Psi square equal to 0. Radial node or spherical node. Nodal surface angular node. Radial node, the circular ring around the nucleus where psi square equal to 0. Rn n minus l minus 1. Nodal plane, the plane passing through the nucleus where psi square equal to 0. Number of n equal to l. Number of angular node in 2s are 0. In S only radial node. Total node n minus 1. Radial probability density. Radial probability distribution curves. Filling of atomic orbital. Above it states that electrons are filled into atomic orbital in the increasing order of orbital energy level. Pauli exclusion principle. Pauli exclusion principle states that in a single atom of two electron will have an identical set of the same quantum number n, l, ml, and ms. Two electrons cannot have the same spin in an orbital. Hund's rule of maximum multiplicity. Before the double occupation of any orbital, every orbital in the sub-level is singly occupied. For the maximization of total spin, all electrons in a singly occupied orbital have the same spin. So spin n by 2. A spin multiple 2 mod s plus 1. Electronic configuration. It is the distribution of electrons into various cells, subcells, and orbitals. Two notations are used. Chromium and copper region. Extra stability of half-filled and fully filled configuration. Exchange energy. Symmetric distribution of electrons. Magnetic paramagnetic substance weakly attracted by the magnetic field. At least one unpaired electron. Diamagnetic substance weakly repelled by the magnetic field. Do not have any unpaired electron. Spin magnetic moment mu. Magnetic moment under root n plus 2 bm. बोर मैग्नेटम n नंबर ऑफ अनपेयर इलेक्ट्रॉन। इसी के साथ ये चैप्टर खत्म हो चुका है।